All right, well, we're into a new week, and this is a week on descriptive and inferential statistics. So it's our statistics week. Some people call it sadistics because they don't like the math involved in statistics. I happen to enjoy statistics. I think they're a very important version of math. In fact, I think some people argue that they're the only type of math that actually relates to the real world or is used in the real world. I don't know if that's true or not, but if you think about it, after learning about statistics, you might think that, hey, this is really a useful type of math that relates to real world problems and real world solutions. So anyway, you'll be reading chapters 17 and 18 on the different types of statistics, learning about those, and also taking the quizzes on those chapters. And this week there is the final literature review due, so hopefully you've been working on that a little bit, reading more articles, thinking what you can add to your preliminary literature review that you created before. The final literature review takes the preliminary literature review and expands it. So again, you're taking the feedback that you received from me on your preliminary literature review, you're updating it, and adding more sources to create a final one with the following requirements, focused toward your planned research study. It is APA formatted narrative writing, like your preliminary literature review should have been. The studies are categorized logically according to focus of studies and results. The writing flows logically and systematically. There are 15 or more sources of information, and an introduction, body, and summary are included. And those introduction, body, and summaries are going to be, well, the introduction and summary anyway are going to be original to you. So it's going to be your own writing about what the literature says. Remember though that your own writing doesn't mean you should put in I, me, or we. You shouldn't refer to yourself in the literature review at all. This is a review of what's in the literature, not of what you think about it. And so when you summarize it, yes, that's original to you, but you'll say something like, overall, the literature says that if we implement this type of study or these types of interventions, then this will be the result. So notice that I didn't really refer to myself in there. I didn't say that I feel like after reading these articles this is the case, or we found. Instead, you're just referring again to what's in those literature items that you've been reading for your review. So that's the way it goes. It's a very formal document and has formal language, and that's why the I, we, or your experience doesn't go into that so much at all, actually. So methods and results, this is the rubric. I'm going to look for methods and results from each reference study. They should be adequately presented. It has a good structure, it flows well, it organizes the referenced studies logically, it uses APA formatting for all in-text citations and for the document. It has 15 or more sources cited and referenced, and proper APA formatting for all items in the reference list. This is what it really comes down to as far as being able to cite other literature. Anytime you do a research study, you have to know what the other literature says out there already, and then you can build upon that literature to make a good study. If you don't know what it says, then you're just kind of maybe repeating what somebody has already done, or doing things that are not useful because the field already has answered those questions. But once you do your literature review, that shows that you are certified, that you can, not certifiably insane, but certified that you can do the research because you understand what's already been done and what still needs to be done. So hopefully your literature review points to some gap that is an area that has not been studied yet, and then that's the area maybe that you will propose in your research proposal, as you have been doing. I have not, by the way, graded the design participants and procedures assignments yet for most of you, so I still have to do that as we go forth. But first, well, at the end of this presentation anyway, a little introduction to statistics. And I want to talk first about descriptive statistics and how those relate to what we're talking about here. So statistics are a set of procedures for describing, analyzing, and interpreting quantitative data. So that's what we want to talk about, is we're describing, analyzing, and interpreting quantitative data. You have to use statistics to do this because they can tell you more than just if you average things out and compare things. If you use a statistical method, you can tell a lot more about what's going on with your research study. By the way, statistics is a subject that can go on forever. I mean, I had to take 3 separate full classes on just statistics for my doctorate. And so trying to cover it in just 1 week is pretty tough. But I hope to give you a good introduction to it this week anyway. So if we look at data preparation, that's kind of the next step. When you do a quantitative research study, obviously this isn't going to work for a qualitative study, right? Because statistics are only for quantitative studies. We'll talk next week about qualitative data. But you want to prepare the data first. So once you get the data from your research study and you've done a study and you have all these numbers, you want to convert them, any data, into a numerical system or categorical organization. And data are usually organized by participant, and you want to double check that data. You're basically going to clean the data, prepare it for statistical analysis. And whenever you report on your research, you actually have to share this process, like how did you do this? What did you do with the data? Because that means that you are being transparent, that you're being clear that this is an ethical research study that you are completing, and so you're going to be open and sharing about the process that you followed. So in this case, this could be an example of a statistical set of data or a quantitative data set. Right here you've got maybe an experimental condition, whether it's experimental or experimental or treatment, or just a non-experimental condition or a control condition. So you've got control is maybe 1 and 2 is experimental. So each ID represents a participant. So 1, 2, and 3, and those could go on down to 20 or 40 or 100 or whatever. And then you have gender, 2 or 1 for male or female. And then you have achievement and motivation scores and grade scores. So you have those variables assessed there. And this is a way that you might want to prepare your data for statistical analysis, as you have your list of participants and what their scores were. And then maybe you want to run some analysis on it to see whether achievement and motivation are different among the genders or between the genders, or with obviously you want to find out about the experimental condition and which one is more effective for achievement and motivation. So the statistics are really a shortcut way to figure that out. Instead of going through and trying to figure out if people are in the condition number 2 are higher or lower than number 1, you can run some numbers on those pretty quickly using some technologies that are available. So descriptive statistics summarize the data. They don't really run a lot of high-end experience math, formulas, but they summarize the data. So you can say something about these. Well, average achievement among those in the experimental condition was 83 points, but only 78 in the control condition. So it's descriptive, it describes what you found so far. And when you're talking about statistics, remember that when you're talking about a sample sample from a population, that's statistics. When you're talking about a population, the full population, it's a parameter. Anyway, types of descriptive statistics include some of these measures of central tendency like mean, mode, measures of variability such as standard deviation, and measures of relationship such as correlation, and frequencies as well, just the amount of time that somebody's responded with a certain response. And then you might actually graph the data as well. This is a graph from one of my studies that says that over 60% of teachers responded that access was an issue, but a lot more responded that beliefs, or high consistent beliefs with technology use, and so forth. So this is an example of graphing data according to descriptive statistics. Inferential statistics takes it another step further though. So descriptive statistics, you might say 50% of people responded this way, 70% of the people responded that way. But inferential statistics take it another step further. It's data analysis techniques to determine how likely results obtained from a sample are the same results that would be obtained from the entire population. In other words, you can really say a lot more with inferential statistic methods. You can say that these results are indicative of what the whole population would probably experience based on my statistical analysis. So if you look here, this is an idea of the graph here. So you have a population, but your research study has only probably been able to reach a sample of that population or a small group out of that whole population, because usually populations are huge, right? You probably can't survey every person in the United States, or even every teacher in the United States, or even every teacher in the state. Usually you're only going to get a certain percentage of people from that population. So inferential statistics helps us to know whether that sample that we got really is a representation of the entire population. And if we know that that is the case, then we can recommend that, a different way to do things based on our study. So that's inferential statistics. It really tells us, can I generalize my findings to a population? What's the probability of being able to generalize those findings to a population? And as we have read about, or will be reading about, there's an alpha level usually, and researchers usually use an alpha level of 0.05, meaning only 5 out of 100 chances that the observed difference occurred by chance. So let's say I did a study and I found that group A really performed way better than group B. Then if I used an alpha level of 0.05, that means that I'm 95% sure that group A would performed better than group B. Not just by chance, it wasn't just by chance. But there's still that 5% possibility, I guess, or 5 out of 100 chances that it was by chance that this happened. So that's kind of, brings up questions about research, but that's the way that most researchers do it, is that 5% or 0.05 alpha level. And then there are different types of errors. Type 1 errors incorrectly rejects a null hypothesis. So it says that there is a difference between the two groups, but there actually isn't. And then type 2 incorrectly fails to reject the null hypothesis. So that means that there is no difference between the groups, but there actually might have been. And those are just the different types of errors that they can. The way they're presented is pretty confusing on type 1 and 2 errors. But if we look at statistical tests, oops, got to get back to where I was apparently. If we look at statistical tests that are used in inferential statistics, though, you can use different tests to determine whether scores are statistically significantly different or not. So you might have group A, which scored a lot higher than group B, but you don't know for sure if that's just by chance until you run some statistics on it. And once you've run some of these tests, then you can know whether that difference is actually just by chance, or if it's actually because of the treatment that you ran, because group A received this type of class and group B did not, and so you think it's the class that affected it. You can't say that it was the class, though, until you run some inferential statistics to determine that. So some of the tests that are listed here can be used. There's a t-test, which is the most simple test you can use to determine differences between two groups, and that might be one that you want to present in your proposal in the end here. I want to run a t-test to determine if there's a difference. And that's only if there are two groups, though, in your study. You can use t-tests. Analysis of variance is a test to use if there are differences between two or more groups. So you can use that for two groups, but you can also use it for 3, 4, 5, 6, and so forth groups. Analysis of covariances determines difference between two or more groups with the control of extraneous variables. You get a little bit more into things with multiple regression. You can look for the amount of variance accounted for in a different variable by various independent variables. There's a chi-square test to determine differences in categories, and structural equation modeling to determine how various different independent variables affect various dependent variables. That's a very confusing one. For the purpose of this class, most of you are probably going to propose to use a t-test or analysis of variance. T-test for two groups, analysis of variance for two or more groups, as a test to determine statistical significance between a group A or group B. So those are just some basic statistics items to be aware of. You'll be reading more this week in your chapters, but hopefully these are some simple concepts to remember. Have a great week.